We just finished up our unit on polynomial equations and polynomial functions, and now we are moving on to Unit 8. Chapter 8 deals with variation and rational functions. Our lesson today focuses on variation functions, specifically direct, indirect, and joint variation. Let's start off with a few definitions. Our direct variation is going to be known as the variable y varying directly as x if there is a non-zero constant, which we refer to as k, such that y equals kx. Basically, what you need to pull out of that is that your equation is, if it varies directly, will be y in the form of y equals kx. Next, we have joint variation. Joint variation will have y varying jointly as x and z if there's a non-zero constant k such that y equals kxz. So you just need to remember that y equals kxz. And it varies jointly just because there's three variables. Finally, we have indirect variation, where if y varies inversely or indirectly as x, then there's going to be a non-zero constant k such that y equals k divided by x. So make sure you get that equation down. You do need to know your definitions because we are starting to put some more vocab into our quizzes and tests. Let's take a look at a few examples. First, if we have to find that variation constant, k, and the variation equation. Here we have for a, y varies directly as x, and y equals to negative 24 when x equals 4. Our first step is going to be to set up a variation equation depending on which mode of variation that the variables vary to each other. So if we have y varies directly, that means I have y equals k times x, which means that I will set up our variation equation and solve for the constant of variation. What we mean by setting up the equation is taking our values and substituting them into the equation. So we would have here that y is negative 24, and we have k times 4, or 4k. We solve for x by dividing both sides by 4, which gives me that k is equal to negative 6. And finally, that means that step 3 is we're going to rewrite the equation with k, our k value we just found, which means that we will have y is equal to negative 6x. And when you get into pre-calc, you'll need to be, and math studies, you'll need to be able to graph those, which isn't that difficult, but for the purposes of our class, we are not graphing. Moving on to example B. In example B, we have the same exact directions. This time y varies jointly as x and z, which means that our equation we're going to use is y equals kxz. And here we have that y equals negative 324, x when x equals 5, and z equals 9. Substituting those values in, you get negative 324 is equal to k times 5 times 9. Multiply out the 5 times 9, we get negative 324 is equal to 45 times k. We divide both sides by 45. Once this is done, we get a value of k equal to negative 7.2. So when we go ahead and put this into our equation using our k value, we get y is equal to negative 7.2 xz. Looking at our final example for this type of problem, we have y varying inversely as x with y equal to 4 when x equals 5. That means I'm going to use y is equal to k divided by x. So we substitute our values in, knowing that y equals 4 and x equals 5. And that gives us that 4 is equal to k divided by 5. To solve this, we're going to multiply both sides by 5, giving me k is equal to 20. When I rewrite this, I get my equation of y is equal to 20 over x.